Okay, so I don't know how well you can see this, but there's a little bit, bit sticking out there.
Yeah,
Um,
I got it.
right? Maybe you can see it in reflection.
Gotcha.
But that is fairly easy to cross going in, and then a
Mm-hmm.
little harder to cross going out, right? Because
Gotcha.
that's the behavior that we want.
Mm-hmm.
So here are the choices that I made. Simple machines. I'm using inclined planes. Okay. So going in, I want it to be relatively easy to close. So I made this a little bit shallower. And coming out, I want that to be not impossible, but sort of medium difficult to open. We don't want it to open easily,
Mm-hmm.
right? So this is a steeper slope. I don't know if you can really see that here on this plot, but or on the drawing, but this is a little bit longer of a slope, and this is a little bit shorter of a slope. And then it's flat in the middle because if it was pointed in the middle, the point would wear out,
Mm-hmm.
right? So we have easy, medium, and wear resistance. Those are the choices that I'm making when I'm designing that little piece that's sticking out. That is engineering.
And what branch of engineering would that fall under? Mechanical?
Mechanical engineering.
Into different
I
things.
mean, you could
Rocket
talk
stuff.
about design for additive manufacturing because I could make that shape.
Uh-huh.
Right? That shape is not difficult to make in three-dimensional printing. It's difficult to make in machining because you'd have to fixture it from a bunch of different directions to get the machine tools in there. Design for additive manufacturing and mechanical engineering, simple machines, materials properties and wear resistance.
Did you go through some iterations looking at different like clasps or anything, or were you pretty set on what just knew just because of your experience doing this?
So I went through a couple of iterations, mostly to get the interaction right. And again, I don't know if you can see this, but I added little ears that stick out on either side of the top here. They
Okay.
stick out just for symmetry. It's the one over here that matters. That's the one that I tested. And so here is the test bed.
Okay.
Um, right? So I 3D printed a section of this, which would
Uh-huh.
be impossible to do in regular machining, right? So additive manufacturing, really easy to make a prototype. It took, half an hour to print or something. Um, and then the question is, what kind of behavior do I have here? Is it enough of an interaction that I'm happy with that snap? Because I don't want it to be too difficult to move,
Uh-huh.
and I also don't want it to. I don't want this thing to stick out so far that it interferes with you getting your finger in there to get the SD card out. So that looks like this. So that's like this. You want to be able to get in here and get the SD card out. If this little nub sticks out too far, it'll
Uh-huh.
get in your way.
Yep.
The other thing that I did was I added material above the SD card slot. So you can't put the SD card into something above the slot and lose it inside the instrument, which was pretty annoying before. Um, so this then, right? So we have that there, and then we push, and um, you'd think it latches, but it just kind of stops. And if you
Okay.
shake it hard enough, it'll fall out. So what we want is to have something that'll stop it falling out. Because if that little card falls out in the field, you're not finding it again. It's much too small.
Yeah, it's pretty
Um,
fun.
so, so there's the little door.
It's brilliant.
And I just found out as I was putting one of these back together, showing you, that you really need to leave this door open when you're putting the lid on, because the lid and the door can interact with each other and it'll bend the door. Um, so, new considerations, order of operations, following instructions, all that good stuff.
Awesome. Hmm.
Iteration's really important.
Hmm.
Imagination is really important. Empathy is really important.
Hmm.
Right? We put that extra piece of material in there to stop people losing their SD card inside the instrument. If you weren't thinking about it from their point of view, you might not care. So, and then I had it before where it didn't have that piece of material. I was like, oh, I can add that material. That's easy enough to do.
That's cool.
Whereas if we had to do this in traditional manufacturing, we would have to anticipate all of this ahead of making a traditionally manufactured prototype. And we'd get to maybe iterate once based on cost. The thing about additive manufacturing, especially plastic additive manufacturing, 3D printing, is that you can iterate kind of as much as you want. And so it lets you iterate and reconsider and do that in a way that is really low cost and quick. That's
That's a
that's why you want to learn these things. That's why we want people to learn to do 3D printing is because that's how you make stuff these days.
I
Um,
agree.
and and even if you're going to traditionally manufacture it, if you can 3D print it to test it, test fit your parts, make sure they're working properly, make sure your mechanisms are actually behaving themselves. Yeah, super important.